Hello everyone and welcome. In this presentation, we will explore how to implement Internet of Things solutions using AWS IoT, specifically without relying on AWS Greengrass. I will outline 3 distinct solutions that can effectively meet your IoT needs. But before we dive into details, I would like to ask a few questions to better understand your current knowledge and expectations regarding IoT implementations. Do you know how many IoT qualified devices are in the AWS marketplace? The total IoT devices known today are 517. Now, how many IoT devices do you think are Greengrass compatible in the marketplace? Out of 517 devices, only 166 are IoT compatible, which leaves us with a coverage of just 32%. Isn't that enough? You might think so, but keep in mind that not every device can be used for every single use case. Customers often have specific requirements such as security and personal identification for workers. In today's agenda, we're gonna explore who we are, some business and technical challenge, 3 solutions, and then we're gonna conclude with questions that you might have for me. My name is Augusto Valdivia and I am a DevOps specialist, part of the digital team at Echechangas. I am also a 4-year AWS community builder. To start, we're gonna start with the business challenge. There are a lot of pressures in our customers that are feeling the need to use the resources like money and time more efficiently. This means that they want to do more with less. Many companies have their data stored in separate places or systems that don't communicate with each other. This makes it hard to get the complete view of their operations and can slow down decisions making. SaaS products are often expensive, especially when companies use many different services from various vendors. This can make it hard to implement advanced technology like digital twins and smart buildings. To improve this, we have recommended to our customers some solutions. We have told them that they should consider using solutions that are not tied to any specific vendor. This means they can choose the best tools for their needs without being locked into one company, helping them to save money on subscription and reduce the issues of siloed data. In summary, the challenge is about finding better ways to use resources while dealing with high costs and disconnect data systems. Now that we learned about some business challenge, let's explore some technical challenge. Currently, only about 32% of IoT devices can use AWS Greengrass. To meet customer needs, we need to work with many more types of IoT devices. The IoT hardware market has not fully taken advantages of what Greengrass can do. This means that many devices are not using its features effectively. And it is important to be able to work with devices from different manufacturers or vendors. This flexibility allows us to choose the best devices without being tied to one vendor. The main challenge is to connect a wider variety of IoT devices in a way that allows us to gather data quickly and securely. We want to ensure that data can be accessed in near real time and at low cost. In brief, the challenge is about expanding the use of IoT devices, improving integration across different vendors, and ensuring reliable and fast data collection without being limited to a single platform. Alright, it is time to explore our solutions. Our first solution is API. This method does not completely remove the cost associated with SaaS products from different vendors. Instead, it helps to gather and centralizing the data from these services. By centralizing the data, companies can make it easy to manage and analyze it. Though this approach is best for applications that do not need real-time data. Companies often charge extra fees for data centralization service on top of regular SaaS costs. Let me walk you through this architecture. This architecture uses in AWS Lambda, which is a service that runs code in response to an event. This event is connected with various vendors' APIs. These APIs can be either cloud-based or located on premises. Then we have the data integration that are scheduled by using AWS Event Bridge, which helps to manage event-driven architecture like this one. After a successfully login, a session token is generated. This token allows the Lambda function to access and request data from the API endpoint for a specific period. The data queries can be customized based on parameters like start and end dates or specific sensor groups, making the process flexible. This method is designed to be low cost and efficient, providing a practical solution for data integration. To summarize, this approach is to focus on centralizing data from various SaaS platforms while using AWS tool to efficiently manage and query data, even if it comes with some additional costs. Our next solution is MQTT. We use a lightweight publish subscriber message protocol that is efficient for sending data, particularly in JSON format. Many IoT devices support MQTT for sending data to AWS IoT Core, which is a cloud service for managing IoT devices. Our preferred method is using encrypted MQTT over port AA3. This ensures that data transmitted is secure. However, there may be a limitation if the sensor does not support MTLS and authentication. This type of authentication requires a device certificate and a private key from IoT Core. This messaging approach is free to use, making it a great option for scenarios that require near real-time data transmission. This protocol is also largely vendor agnostic, meaning it can work with devices from various manufacturers without being tied to one specific vendor. Overall, this protocol provides a flexible and secure way to transmit data from IoT devices, making it suitable for real-time applications while being cost-effective and compatible with a wide range of devices. Last but not least, Webhook. Let me walk you through this architecture. A device connects to AWS IoT Core using a supported method, sending credentials like username and password with the request. Then it happens two things. AWS IoT check if the request included in the authorizer. Then it looks for a default authorizer set for the endpoint. If the authorizer is found, AWS IoT Core triggers a link AWS Lambda function to handle the process or the request. The Lambda function processes the credentials and decide whether the connection should be allowed. Then, the Lambda function sends back a decision along with a policy document that outlines the allowed action for the device or devices. Then AWS IoT Core evaluates the connection request against the provided policy to determine if the connection can be accessed or if it can be proceed. Then, once it's connected, the Lambda function might not be called again for up to 5 minutes if there are no MQTT actions. After this time, it will follow the refresh times specified in the Lambda function to avoid excessive calls. To bring all together, this process involved several checks and validations to ensure that devices can securely connect to AWS IoT Core with decisions made based on defined policies and credentials. Now, this is the conclusion of this presentation. Thank you again for attending this talk. I hope these three solutions will bring value to your current and future IoT development. If you would like to learn about the list of IoT qualified devices in the AWS Marketplace, please reach out to me via email or LinkedIn. I also invite you to read my articles about IoT in our community space on the dev.io website. And now, I am more than happy to answer any questions that you might have. Leave it in the comments and I will reply to your questions as soon as possible. Thank you again.